Another Sony TV, KDL48W590B. That's the TV inside. We have, this is a small DC to DC converter plus the LED driver board. So this TV it works with external power supply. You can see it here. Like it's go to this ones, this kind. And we have the main board. We have the signal board. This is just the inputs and the RF, the cable connector, Wi-Fi card, IR sensor, LVDS cable. So it's kind of simple TV. Yeah, before I start checking this TV, and let me let you know, the Sony motherboard is very tricky. Sometimes the board it works, because this has happened to me before. Like, you want to fix the backlight, you change the backlight, but you forgot to connect the LVDS cable. You turn on the TV, the motherboard it's stuck at the green and orange light, and this is a firmware issue. It's like when the TV detects screen not connected or backlight, something going on, it's go to this safe mode. Many times by hard reset the TV or update the firmware, that's going to fix the problem. But other times the TV completely gonna stop working. You're gonna need to replace the main board, or you're gonna need to change the NAND, reprogram the NAND or change it. So anytime you work on the Sony TV, do the same as we were doing in the plasma. Be sure everything connected before you test the TV. So we go for this one here. I'm gonna plug it to the power. So usually there is a light here, no light, no LEDs, no standby light. If I push the power button here, it's nothing. It's not responding to the power button. Like this set is completely dead. So let's check some voltage. So voltages, and here in the input, gonna check here. This is a little fuse. We have 19 from that side. If we check the other side of the fuse, 19, there is another fuse here. Here is 19 volt. The other side of the fuse, there is 19 volts. So the fuse is not open. Then we go check. You can see this connector is going to the motherboard, is go to here. Let's check if we have the voltages here. So we check all these dots, these test points. No voltage. I guess this one should be like a backlight signal. Here we have 3.3 volt. That's good, because that voltage is important for the controller. 19 volt here. 19 volts. So we have 3.3 and 19 volt this side. We go the other side of the board. So here 3.3 in this carbo resistor or conductor. We go to the power button, and we're gonna check here for 3.3 volt, the controller volt. So here is 3.3 in the middle pin. Let me try, because I need to push the power button when I am to see if the power button is gonna respond to the. Let me just try to put the probe in the middle pin. We see 3.3. I'm gonna push the power button. You can see it is go to 0, then back to 3.3. So the power button work. It's shorting the controller switch button for to turn it on, but the TV still not turning on. We check these coils for the voltages. 0 volt, 0 volt, 0 volt, 0 volt. Yeah, we check all these coils. 0 volt. Come close. 0 volt. And they check some fuses here. There is a small fuse. Come close. This is a fuse here. If you see F a number, it means that's a fuse. So you need to check it if that fuse open. Let me show you one here is close to you. So there is a fuse, and the fuse is here. So that fuse is good. So let's keep checking the capacitors by the processor. So from the first test, we know the problem is here, not in the signal board, because this board, it doesn't do nothing. This board is giving the voltages, but we have no standby light. So we know the problem is somewhere here in this board. So check these capacitors. There is a little fuse here. Fuse is good. Okay, that's one okay. Okay, we have a low reading in these capacitors. We have a low reading in this capacitor here. We check the capacitor around the ICs. There is another fuse here. Fuse is good. Here, so we have this one is low. This one is low, this one is low, and all these capacitors is linked to this DC to DC switching power IC or power supply. This is a small power supply, DC to DC, and this is the IC that's controlling it. So if we put this one in the ground, or let's put this one in the ground, and we check. This one should be the ground. Okay, this one is bad. Get the next another two like this. So I'm going to check the voltage, put this one in the ground, then I check in this little IC. Okay, yeah, we have some weird reading over there. Let's check the resistance over there. So must be this is the ground. So here we have 3 ohm. That's very low. 3 ohm here. $19 ohm in this capacitor, and all these capacitors is connected to this IC. I do have another board like this one, came from a cracked screen TV, and let's see what's the reading we have in this board. So we go to the same IC and we go to these capacitors. So in this capacitor we have 40 ohm, and this one's here we have 3 ohm. This is not normal. In this capacitor here is an open line. in this one here is a 20 ohm. This one here 40 ohm. This one here is a 2 ohm. So I'm gonna go with the IC first. I'm gonna remove this IC and see if that's gonna look for a replacement one, and after I remove it we're gonna check around to see if this still gonna have the shirt. So let's remove the there is a line that's the IC direction, so we're going to remember how the IC is on the board. So I remove the IC, that's the IC, and let's check for short. So wait for the board to cool down a little bit. So we still have 20 ohm over there, we still have 3 ohm here, and we still have 2 ohm here. So it's not the IC. I'm gonna take some that's capacitor. Alright, let's test. Still have low reading over there. Still short. I'm going to check the capacitor to see if the short is before or after the IC. If I check the capacitor and the short is gone, it means the short should be like somewhere in the processor. So I removed the shirt, it was this side, not that side. So it's in the look like it's in the output of the, and I want to see what this power supply is for. I connect another board to the same TV. So this board is from a different size TV, so 48 I think, or it's a 40-inch TV. So, and here, let me push power button, you can see the light, and they check in that coil. We have 5 volt. So this power supply is 5 volt. So next, the 5 volt is powering the USBs and is powering the other ICs for like 3.3, 1.8, 1.2 volt and something like that. So you can see here is the orange and the green light because the board is for a different TV. So we can use this board if we do the firmware update, software update. If the board accepted that update, it's going to turn on. But I want to fix this TV, this board, so I can share the repair with you before I go with this one. So this is a 5 volt. So let's check where this 5 volt. So this coil here is a 5 volt as well. That's the output. When you test in the coil, you are testing the out. When you test in the B capacitor, you are testing in. So like the in of this power supply, this side is a 19 volt. So 19 volt is go to this IC. Let me see where it's go. Yeah, it's go to this IC, and there is a diode and the coil. So it's go to this IC, there is a diode and coil. So that 19 volt is become 5 volt here. So we have this coil is a 5 volt and this coil is a 5 volt. This coil here is a 1.7 volt. This coil here is a 3.3 volt. This one here 1.5 volt. Yeah, I want to know where that 5 volt is go. So let's unplug the TV. And Amir, come hold the phone. So this 5 volt. So the 5 volt is could be feeding other power supply. So it came 19 volt. Then this power supply here is transferred to the 5 volt. Then the other ICs, they use 5 volt to transfer it to the 3 volt, 1 volt, and like that. So this 5 volt here, I want to know if it's go to any of these power supplies. So I'm putting it in the coil. Then it tests this capacitor is here. And if we check the other coil, let me try. So let's try again. So we're gonna check in the B capacitors. Still have the short here. Yeah. Do I go to this USB here? Yep, we have a short as well, because the same 5 volt is feeding these two USBs. So I'm gonna go to this. Remove this IC. Yeah, I'm about to give up in this board because I've been removing a lot of components, and that short's still there. Yeah, the shirt is gone. The shirt is gone. Yeah, no more shirt. No more shirt. Yeah, I did put all the components back, and I replace this IC and the shirt back again. Yep, the shirt back again. So yeah, it's giving me a little bit hard time here. So I'm gonna remove the both ICs for the USB. Could be both of them are bad. That is one. this too. The shirt is gone. I don't remember which IC I replaced, so I'm gonna go with the 2 IC this time. I have this Sony board. It's kind of a little bit different, but the IC here is the same. It's a K2. Let me see if I can zoom to it. Yep, this IC here is a K2, and this pen is going to VCC USB. This pen here is the output, and it's the same here. This pen here, let me see if I can. Alright, yeah, this pen here is the output, VCC output. So let's replace both ICs. How I solder this small component. So just say parallel flux. When you put the component, press it a little bit, then move it right and left. Yeah, be careful the direction of the IC. You can see this one has 2 pins this side. This one has 2 pins and to the bottom. The middle pin is not connected. So let's test the shirt. So no shirt. Let's test it. Yeah, the board still have no power, so there is no shirt this side, but there is a shirt in this capacitor here. It's about 20 ohm. So the day number 2 in this board. So yesterday it took a little bit of time, so I just left the board at that point. When we take the 2 short ICs, USB VCC 5-volt ICs, this one here and this one, or 5-volt the MOSFETs, and they test the board. The board still not work, and they still have low ohm, like about 20 ohm, and this part here. See the multimeter, low ohm in this part. It's at 22 ohm. But other here where we had like bad short, this one is good. So could be when the USB's IC is shorted, could be that line sometimes is shorted as well. And I did bring the external power supply. To help us make more test. I already removed this IC and the capacitor. The short's still there. Like this is better, I think. So we set up the power supply at 1 or 2 volt. The amps, so we touch together, it's going to show the amps. Let's go to 1 or 2 amp. So the negative side of the power supplies go to the ground. Then I'm gonna touch the positive side of the capacitor. You can see this needle is moving, but it's not that much. So let's increase the amps, nothing. Then let's increase the voltage. Put this one good ground. Okay, so it's grounded now. I hope it's the short is not in the processor, because if the short in the processor in the NAND, I don't know what this IC is. The time like these ICs is, I can't replace them. So we just put it here and start checking what component is getting hot. I'm still feeling something getting hot this side here. Yeah, definitely this side. Oh yeah, something is getting hot here. Yeah, something is getting very hot over there. When I was follow the traces, I went all the way to this point here. To this point here. Then after that, I don't know where is the traces go. I did search all around. From this point here, from here all the way to here. So that's where the traces is go. And I did look other side of the board. There is a small 2 dot here. This is the one that's on the edge. That's the one is connected to this one. So without no schematic, it's kind of hard to deal with these boards. But let's see. So it's going to this point here. So what are we going to do next? Let's put some alcohol. Let me zoom in that spot so you can see. So this is the HDMI control chip. These traces, they go to HDMI. So a lot of time this HDMI chip, it's go from power source. The power source like high voltage reach the other device, and the other devices send the high voltage to the HDMI and burn these chips. So let's put some alcohol. So put some drops over there. Yep, I see something. You see it? So these 2 resistors here, that's what is getting hot. So let's make more check. This is going to be a long video, but this is how is the board repair it's go. So let's check. I'm gonna be sure this line is connected to here. So from here, so here we have 20 ohm. You remember the 20 ohm to the ground that we have here 20 ohm to the ground, and we have here 20 ohm to the ground. The other side, yep. So that capacitor that line is connected to here. So we have from here to here, it should be like 20 ohm, yes. And from here to the ground, it is gonna be low ohm, 3 ohm. So basically it's not a bad capacitor. I don't think it's a bad capacitor, but I think the other side of the capacitors is shorted to the ground. Let me bring the other board here. So we test this line to here. Yeah, from the other side of the other side of the resistors to the ground is nothing. That trace, one side is go to the IC, the other side is go to this resistor. So you can see this trace is go from the first pin, it's go all the way to these resistors, and this go to this resistor here. This is a 4 resistors in one. So kinda I will go with the HDMI IC. I'm gonna remove it and see if that's gonna take care of the shirt. we're going to check this side to the ground. The shirt is gone. You see that? The shirt is gone. Here no shirt. We had 20 ohm before to here, to this capacitor, side of the capacitor. So this HDMI IC is bad. I'm gonna look for a replacement one and see if we can get it to work. Yeah, I found this Sony board. It looks like it has the same HDMI chip. So be careful to the dot. That's the direction of the chip. The pin number 1 is here, and there is a little dot mark on the board. Yeah, the TV works. Yeah, you can hear the sound.